Welcome to the office. Welcome to the office. The professor's office. I might need to get some more coffee. It took me a while to get set up, and I'm still setting up. Hold up. Yo, yo. No, okay. Sometimes my computers make noise. Anyway, for those that have been joining me in my office hours, um, some may be wondering what the heck I'm doing. Couple of things, actually. In fact, I'm trying to figure out the best format to do these, but think of the actual factor of open office hours where anyone can come in and communicate with me, talk with me, ask me questions, maybe running through some problems that you may need to go through. I'm open to doing that stuff on live. Currently, as the title shows, I'm going to go over just some kind of random stuff now. I'll probably be using this in future videos, maybe what do you call those little shorts that I've been kind of practicing. I'm still working on my video editing, so give it time. Uh, but I wanted to essentially record this stuff at the same time, um, reuse this content that I'm basically streaming right now uh, for the future. And not only do I want to just record stuff and put it on my computer, I'd like to interact with people if, they're watching and I'm capable of maintaining this sort of non-ADHD communication format because I'm horrible at that. I get focused on one thing, hyper focused, and then someone comes in, says hello, chats with me, and then maybe like 5, 10 minutes I notice and I reply and they're gone. But everyone's got a little ADHD nowadays. So, yeah, I mean, you can ask any question mathematics wise, programming wise. Um, there's a lot of stuff I support, and I think my stream is missing a little something. Hold on a second. So, I'm just essentially trying to be available to my community. Yep, there it is. And helpful in any way, shape, or form. Hold on, let me put that here. These are essentially ways you can communicate with me, get in touch, trying to see if it's good. Does it look good? Is it weird? Is it too? It's fine. Okay, cool. Uh, Basically, yeah, to be open to the community, and this way, literally having like a actual office hours, and I'm trying to do it daily, so I'll be available around this time, which for the East Coast, United States, America, North America space, pretty darn early. But I'm thinking maybe. Because I have basically students in the afternoon slash evening in the Eastern time zone, and my sleep schedule is all over the place because I live in Europe. So working in a North American Eastern time zone plus 7 hours tends to basically put me at around a good 4 or 5 o'clock in the morning local time uh, sleep. I mean, sometimes I even go until 5:36 and the sun comes up and I'm going to sleep. So very odd timing. I know it is what I've chosen to do as a remote educator. I get to work from home. I get to organize myself from home, but it does come with a caveat. Odd hours, plenty of outside work that doesn't involve the actual sessions. And as a teacher, that's kind of the thing that doesn't really make sense to me is how can teachers get paid so little when they actually do a lot of work outside of their school hours? Like you have students you're catering to, you have basically to bring all that work and grade it. Maybe now it's a little bit different with AI and these kind of things, but in a general sense, a teacher does a lot outside of school. So how do they get underpaid or they don't even get paid for that part? So this is the good thing about being an educator on the remote aspect is I have full control of my schedule. Um, and of course, as I do have my private tutoring sessions that you can find on Patreon, I can basically try to give the best offer I can for all the students that need help, but also consider that most of the work does belong in the preparation aspect. Not every student can be helped right away on stream or on the actual one-to-one session, which basically looks like this. I mean, we have a little whiteboard here. Um, Instead of my desk, I normally show my face, but hey, this is an office, so here's my setup with a couple of caveats here, an extra screen, my little extra computer here that manages notification statuses, and I should probably get this to keep an eye on my chat. How come it's not doing the thing here? This one's not loading, but the other one is odd. Why is that one loading, but that one's not? That's a little bit of a caveat there. Yeah, sometimes the consistency of making sure that I can respond doesn't quite work as hoped. So I can see my chats. If anyone does message, I'll let you know as soon as I can. If I'm in the middle of like something, I might not see it right away. So don't get discouraged. I'm literally going to be here for a couple of hours sipping coffee, probably making more coffee. Mm, but um, I want to essentially record content. This is the best way. Everyone has different ways of recording, right? I'm more the improvisable individual that can essentially go with the flow. Um, I mean, in the case scenario, I can prepare with a certain subject. Like recently, I have a new calculus student. I mostly do sixth, fifth grade math up to 12th high school. So there's a quite big diversity. But then you got some students that have like AP calculus. The last time I did calculus based was at least 3 or 4 years ago. So it's been a while since I've actually gone through the whole structure to remember it on the fly. So those cases, I'll go through, hey, what do you have to essentially do? What subject is it? Limits? Is it analyzing graphs and their domains and ranges? Um, is it derivatives of regular values or radian values or degree functions and all kinds of random stuff that you could find in calculus, which we'll see a little bit more of a layout here for anyone that's interested in actually how math is organized, because I've always introduced it this way, and it's just like any language. But we'll get to that point in a second, because right now you'll notice there's two pieces to mathematics like any other language: vocabulary and grammar. That's that's the words I'm using right now. But we'll get into detail there. So improvising for me is kind of like, because I guess done this for so long, 15 years plus, on a one-to-one basis, where a student tells me what the issue is and I can go directly and start working out problem, asking questions, analyzing what the student's response is, and adjusting the problem based on their um, kind of what they don't understand and what they do understand. But because every student's different, we all go through this tango in the beginning of questions asked, answered, until I can kind of pinpoint where the student is. So my sort of flow in recording as well and in teaching is improvisation. Um, it's less robotic, uh, it's much more appreciated by students, honestly. I've tried the whole, let's go through these bullet points and get through this PowerPoint, but that doesn't work with students. It works on a more dynamic, interactive method, which also is a problem with artificial intelligence. They kind of have that sort of bullet point based process. So I like to just go with the flow. So I'm recording. If you ask a question in chat, somewhere around here, I'll make sure to, take a moment and answer your question. Um, I really want to make more coffee. I really want to make more coffee. Coffee, coffee. I'll probably take a little second before I do go make it. But let me. Okay, so I got Kick and Twitch open. Hello. Yeah. Oh, nice. I should. The problem with YouTube is it never has a consistent live chat. It's always based on the current live being activated. So I gotta constantly go back to a new chat every single time. So let's see, I'm gonna pop out a chat here from YouTube. So I'm gonna watch YouTube. No, that didn't even pop out, right? Really? Come on now. No, I can't pop it up. Great. YouTube just has a very, very bogged down system, man. It's no bueno. I'll just keep it this way and kind of flip through them as we go. So, what are we looking at? Well, as before mentioned, we're really going to be going into a couple of pieces here. I'm going to go through just kind of the, again, basics of mathematics. Not even basics, just like a categorized branch out to understand where math is, what parts come in where. Because a lot of students I've had, for instance, come to me for calculus problems, and it ends up being algebra that they're having issues with. And I'll explain why based on this diagram. This happens very, very often. In fact, statistics, calculus, trigonometry, geometry, all of these, they understand the vocabulary, right? So if we think of mathematics as a language, which it is, not a com- communicative language, which it is. We communicate values and observations we have in reality in mathematical terms so we can explain them in a more organized manner when it comes to calculations, predictions, and planning. For sure, it's a communication language, but it's not like, I am hungry, please feed me. It's not that kind of communication, right? But math has two factors involved, just like any language. We've got a vocabulary, a set of words, a set of formulas with titles and names and all that. That the best case scenario and the easiest case scenario for a lot of students is just memorizing. Even if you're horrible at memorizing, you take flashcards, you look at those flashcards over and over, you can um, brute force those equations into your memory. So this is why when we're going through geometry, trigonometry, we're all kind of going through different types of subjects. And with each subject comes a set of vocabulary words that specializes in those subjects. Um, but being it that this is just memorization, this is kind of like the strength for a lot of students. They can memorize an equation. The problem is when they come to me with, hey, here's the equation, I've done this exactly as I'm supposed to, but something's not right. So we come down to grammar, algebra, algebra. The heart of algebra, which is one of the things, technonomics. Hello, bud. How you doing? Technonomics. Um, so as far as the grammar and mathematics goes, we think of it as a way that we work with those vocabulary, right? If I speak in a specific language like English versus another language like Bulgarian, Japanese, each language has its own formula for creating sentences. Mixing words up makes sense, no, if not to make the right choices. Obviously, you can kind of decrypt what I just said there, but there is that same concept in math. You may have a small, decent grasp of the grammar of mathematics, which is algebra, but if it's not so fluent that you're speaking without even thinking about it, as we normally communicate, then there will be times where a negative flips accidentally, where you have an issue with carrying over numbers, and just something small can change the whole problem. Uh, so even that sentence that I scrambled as I was speaking, it still is comprehensible on an English level. It doesn't normally work the same way in mathematics. You make one small mistake and boom, the whole problem is going to be either answer is negative and you got a positive or a couple of decimals off, especially in the higher maths. So the highest problematic zone for, I would say, 90-80% of students is the grammar. Because it doesn't matter which subject you're in as far as vocabulary, basically absorbing and memorizing and putting it on a flashcard and going through the whole process. You will essentially run into, am I using these vocabulary words correctly? And that's where I come in and I'm like, all right, show me how you do it. Give me some previous work that you've done. Uh, Ideally, a test because you're stressed during that test. And when you're stressed during the test, those are where the errors start to pop up, which is in the case of, well, test taking skills and strategies to approach tests to optimize your grade. But in the end, it really is the case where it's the algebra that pops in. So every single calculus, trig, statistics, geometry student that I've had, they understand the vocabulary, they understand what a rectangle is, or what the formula or identities um, of the unit circle are. It's just when it comes to using them, that's where it breaks apart. And here's a little bit on the subject geometry, right? This is how we can connect ideas, not only just use flashcards, but connecting ideas in vocabulary that you cannot technically do with grammar. If we have a box, any rectangular prism, box, square, whatever, the default kind of template is always base times height. That's it. But then you observe a little bit further, you can catch that a triangle is half of that box, no matter which way you diagonally slice it. So what's the formula of the area of a triangle? Well, it's b times h just like a box. You just put a half in the front. And these things tend to naturally occur, and whether we realize it, maybe we don't quite realize it, but memorize through flashcards, and maybe one day be like, hey, is there a specific reason why they both have base times height and only one has a half? And then we draw a line through the middle of the diagonal square, and we're like, oh crap, there's an actual triangle in there. So these are the vocabularies that can essentially come through connections of remembering, flashcards, all kinds of methods. But when it comes to the grammar, we've got two methods, and we know PEMDAS, GEMDAS, what was the other one? BEMDAS, brackets, BEMDAS, PEMDAS, parentheses, GEMDAS, groupings. It really depends on what part of the world you're here. I believe in the European area, it's GEMDAS for groupings or BEMDAS for brackets. But I grew in the United States and I learned there, so PEMDAS was the obvious case that I was taught with. And in the end, it just means a grouping of things that normally is with parentheses or the acronym that they put to remember it. Please excuse my dear Aunt Sally. Now, when we're dealing with just numbers, we approach PEMDAS from left to right. We hunt down parentheses first. We do the parentheses themselves inside a parenthesis, not outside. We activate exponents, we double things, whatever we have to do in multiplication exponent sense. Then we pass down to multiplication division. We apply those particular operations, and then finally addition and subtraction. However, this is where algebra steps in and says, hey, now you don't have numbers. Here's a letter, and here's a whole alphabet if you'd like. Well, best case scenario that you can really work out this consistency or inconsistency and the change of atmosphere. Well, you're basically having letters in your alphabet or in your numerical soup is you're applying PEMDAS backwards. You're taking what you already know about the operations at hand and you're clearing things out in a backward sense. So this is where logical troubleshooting and kind of just the way you calculate things comes in. This is not memory anymore. You can't always apply memory. You can kind of separate the two pieces, PEMDAS and left to right, and then PEMDAS right to left. SAD MEP, if you want to call it that. Um, but the actual case for memorization becomes a little bit more obfuscated because, yeah, you can memorize these two things, but are you applying those correctly? But in the end, if you can identify where your strengths are and where your weaknesses are, that's the focus you want to turn to, right? And again, generally speaking, if you need any actual personal help with any mathematics, visit my Patreon. As far as tutoring goes, what's this updates? I have pretty reasonable prices for the experience that I've provided. I have a lot of reviews of students that have had essentially fast-paced and quick learning processes with me, um, as opposed to other tutors and teachers that may take longer. It's because I customize the session to the student. I don't approach anything as a cookie cutter method. Um, that's the problem with public education. They try to make everyone learn in the same method. But I identify every student's different. You've got visual creatives, they're going to do great in geometry. They're not going to do so great in logic. Absolutely not. The brain works in a mysterious way of twos. Maybe it's not a half hemisphere and the other half hemisphere, but creative individuals do have the tendency to do better in geometry. You're doing visual observations. You're cutting squares in half and you can visualize that. The best case I can really apply this is I had a student that I taught that was blind, and I had to use his hands to actually help him visualize what's happening on a XY axis. But once he got it, he was able to see that without his eyes, right? Being able to see something without applying the sense of sight is what we call the imagination. The other hand of that is logic. Those that play chess, those that play RTS games like StarCraft and so forth. Um, they're not going to do so well in geometry, and I've had that experience as well. But they're going to get the grammar down strong, super well, whatever wording I want to use there. They're not going to have any issue with how to combine numbers in which order to just follow the process each time. And then when they see something tricky, they can kind of navigate through the logical conclusion of how potentially to go about it. But this does really separate the two cases here. For grammar, it is more of a logical space, and for memory, it is a bit more of a creative G. Why'd I put a G? A creative space. And there's nothing wrong with either one. You just have to know your weaknesses and focus on them in order to make them strengths. Just because you're creative doesn't mean you can never be logical. Just because you're super logical doesn't mean you can't be creative. I grew up super logical, but I started eventually applying a lot of art to my things, drawing, doodling on my papers, applying different colors to help me visualize things and separate ideas, just as you can see on this board here. And eventually, with just practice and drawing stick figures and expanding from that, I was able to kind of be a little bit more creative. I'm still inflamed in the logical sense, but I do have a creative tendency for style and adjustments to visual aesthetics. Um, that it is, I mean, it could be at least appeasing to me, not to every single person, but at least I have a sense for that. So that's kind of the outline for what mathematics is and how it's really focused into two groups. For most of sixth grade, I mean, honestly, I looked at some syllabuses for a lot of standardized mathematics. And first grade to, I'll call it fifth grade, you focus on addition and subtraction, what it means to add, what it means to subtract. You have two apples, you take one away. One's a plus, one's a minus. But because of the logical incentive here, that this is a part of PEMDAS, it's just the first two or the last two letters of PEMDAS. Those are practiced until like kind of like the logical skill unlocks as a kid. Sometimes I feel like it goes on for too long and some kids can really get it real quick and you can take them to multiplication real quick. But they don't do those until they get down to like fifth grade, sixth grade, where you start to really analyze fractions, probabilities. Um, so there is a kind of caveat. I feel like the North American or Western side of the world does teach math a bit slow, which kind of um, handicaps a lot of students from basically expanding on mathematics when they're ready to, which some have a earlier logical strength and they can expand on math much faster than others that have creative strengths that may take longer. So I don't agree with the fact that addition basically happens between first and fifth grade, but hey, addition, subtraction, they don't even do negative numbers. God forbid you move a 4 minus 2 to a negative 2 plus 4. It's the same thing, by the way. Spoiler alert. You're still going to get 2 as a positive. But that small little move really does scramble the logic of what a student normally understands up to that grade 5, 6 level. So I always make sure it's very obvious in the case, which I can go into, but I'm still providing more of an overview until we get into more specific details here. Then sixth grade, get some probabilities, fractions, ratios, multiplication starts to be more prominent. Multiplying by decimals and fractions becomes a little bit of a wrestling match with a lot of students, even though they're essentially the same. Um, but the meaning behind multiplication of a decimal versus a multiplication of a fraction gets lost. But I mean, we can kind of still do it when we're dealing with like 20% off, right? We can still mentally figure out an estimate of how much 20%, off a specific product will be. We're kind of conditioned like this through, well, the numbers that we see. Originally 9.99, 20% off, 79.99. And then we can calculate maybe an estimate. Oh, it's like 20%, $20 out of 100, something like that. So those are the kind of pretty decent skill sets that I've seen that don't necessarily come from learning at a school just by literally watching advertisements and commercials. Um, but it needs to be fine-tuned, and that's the big problem there. And then algebra starts really playing a big part, 9, 10th, sometimes 8th if you're early. But like algebra 1 and 2 are going to be your main focuses, where variables become a very big play on things. Um, hmm, maybe I should expand on this. All right, this is one of my students here. Hmm, I'm wondering how to reintroduce this idea without having to rewrite everything. I'm gonna make a new page. How about that? Call it office hours. There we go. Can be a little section down here. Okay, yeah, it's already at the base. So let's take a look at that. We're gonna zoom out. I'm gonna express that same concept into a bit more detail because that student I was teaching was like sixth grade, and he was already going a little bit further with the variables. Just to kind of give him a push forward. I didn't expect him to understand every little detail about variables, but I do like to introduce, especially when he's already caught up with everything else, is really good student. And there's kind of like no reason to keep doing the same things over and over. So I kind of pushed him a little bit forward, and show them some ideas that he's going to run into very shortly. All right. And here's how I would introduce it to any sixth grade individual entering this factor with some caveats. I'm going to move around subjects a little bit. But here we go again. So mathematics comes in two flavors. You've got the vocabulary and you've got the grammar. So vocabulary, of course, comes in factors like geometry, learning base times height, learning anything involving lines, linear equations, right? Geometry specifically, I wouldn't say lines are involved, but still, like a actual geometric shape has edges, which are lines, which is a concept you should kind of feel comfortable with when going into geometry. So I would say even further, you've got like pre-algebra, where you're going into the actual linear function, what an x is and what a y is, as far as dependent and independent variables. I flip them around, so don't confuse those two. Um, so that kind of works its way through. So x and y, shapes and areas. You're gonna go through eventually trigonometry, which is now very interesting stuff. It's waveforms and unit circles and A lot of interesting coordinated systems that, well, a lot of it comes from memorization. So again, vocabulary is going to be specific to memory. Flashcards, brute force it if you can't remember something. Do it over and over and over on paper until it sticks. But grammar is going to be our logical. Can we reason the path we have to take in order to find the final answer? That's important. And honestly, that's one of the things I see a lot of people nowadays missing. Probably because it's a part of math that no one really dove deep to understand because they were kind of happy with the vocabulary, just minimum enough 70% grade C just to get the vocabulary set. Never mind, they made mistakes in the process, right? Um, some teachers will let that go and be like, oh, you got the equation right, you plugged it in the right place, but your math's a little odd, but that's fine. I'm going to take away 1 point. That's fine, I guess. If we want to give everyone a trophy, that's a reasonable thing to consider. But logic is so important. And a lot of my streams, videos, and everything I create will be based about logical analysis completely. Um, whether it's social issues, whether it's market analysis, which I do, whether it's mathematical processes, teaching, um, heck, whether it's survival games, trying to figure out based like start from scratch survival, what's the first thing you need to do? Huh, logically, you need fire. After fire, you can start getting water or purifying water. There's other ways you can purify water, but specifically, you can purify water. And then further in, you can start cooking. And then you have the base survival pieces set, water and food. Shelter comes after. And it's just a logical perception of like, are you considering the path of optimization, or is the rain getting in the way and you're doing shelter first, wasting time until you starve, and then focus on uh, the fire, which will bear you food? Different factors involved, absolutely different factors, but logical deduction is a bit of a, what's the word? It's almost becoming a folklore of a civilization that once used to think efficiently. So I promote that. I promote logical troubleshooting. After that, of course, we've got calculus. Still not hard. All of these are on the equal base level. Pre-algebra, geometry, trigonometry, calculus. They're all on the same base level because all of these are just formulas. Analyzing graph, domain, and range. Uh, functions inside of functions. And then domain and range. Basically understanding a bit more of a interactive form of mathematics between different types of functions. That's one case scenario. Then we go into the minuscule limits. As a limit approaches a certain value, certain number, we tend to get to a certain point of analyzing still further specific details and meanings behind the math that we already know based on the previous. Now, the grammar, again, PEMDA specific. I don't want to highlight it as the main, but it is going to essentially be of the main because we're going to start with addition and subtraction. Let's take an actual path to mathematics here. If I had values like 7 minus 3, this is where it confuses everyone. Not this particular piece here, but we don't consider a couple of factors that are invisible, or just one in this case, but there's many that I call mathematical instincts. The first is that there's a plus in front of 7. Never. Never do I see anyone really get this until it's being presented, detailed, or reminded over and over for us to observe that factor. But then what do? That's a value of 4. Now, the tricky part is when we swap these values. This is where everyone starts to fall apart. Every student I've had essentially looks at this and says, I have no idea. Negative 10? Is it 10? Is it negative 4? The factor is that nothing really happened other than me taking the original equation, pasting a copy of it. Uh, really? No. Not as a piece of text, please, or give me the full image. Oh, oh, it's doing this automatic paste. Oh, let me see if my mouse can do better here. Image, right? Okay, well, that's not an option I had earlier. Let me move this down a bit, paste the same thing here. So I'm taking the exact same thing, but the only thing that's really changing here is I'm actually just grabbing things and shuffling them around. Oh, it's just a straight up image. All right, let's do this one. That's all I've done. The answer is still the same. The answer still is of the exact same value because nothing really happened when we swapped those numbers. We have a couple of properties in addition and subtraction. If you add two numbers in any order, it doesn't matter if you change the order, it's the same value. So what is it that confuses students? It's the leading minus. The leading minus gets in the way because they're seeing something they haven't seen before, but they're not associating what it means. Any value, any operation, you can think of this as a plus 7 or just straight up attach it to the 7 itself. It's a positive 7 off the bat. The 7 is a positive value. And now you're mixing it with a negative 3. So the way we even speak math sometimes gets a little confusing because when we say 7 minus 3, we don't associate the minus with the 3. We think of it as its own entity in the middle, but there is literally a combination. Um, every single sign operation, when you're thinking pluses and minuses, it's really sign, even though we can operate with them. This is where it's like ambiguous. They're the same thing. In addition, subtraction, they're the same thing. Oh, why am I down here now? Excuse that. So whenever we attach signs from the left to the right, the sign or operator from the left of a specific number, attach it to the number on the right, then you have the freedom of moving stuff around without having to lose any information. So I can bring this back to its original format. And again, it still makes perfect sense because nothing changed. The 3 is still negative, the 7 is still positive. So in the end, nothing actually changed. This is an important factor here to remember. And you've got some shortcuts to consider. If you're adding two numbers, or if you're putting two of the same signs together, how about that? Adding two numbers, you're going to end up with addition, the operation of adding. But even in the case of two negative numbers, you're still adding them together. That another one that confuses students. Why am I adding two negatives? Aren't they minus? Aren't they subtracting? Aren't they supposed to represent removal? Well, if you don't have a positive to remove from, and you start with a negative, like owing someone $3, and now you have to owe them another $5, aren't you losing more as you have already lost, or you're in debt more from your original debt? So if we start with -3 and then go to -5 and say, hey, I was $3 in debt, or I owed you $3, and now I owe you 5 more, don't I owe you a total of 8 together? This is why addition still works with two negatives. We don't really describe this sort of situation very often. I don't at least recall it being so thoroughly examined when it comes to learning these pieces, these operations. So yeah, the confusing factor is you're adding or throwing in writing a negative in a place where normally we would consider, hey, we're so used to seeing plus values because we don't even think about the plus in the front. We just think of a 7 as a 7. We don't think of a 7 as a positive 7 minus 3. And when we don't observe things in a much broader sense, the fact that signs attached to left, the left sign attaches to the right number, and these are two different attachments here, we start to really look at addition subtraction differently. That can make this make more sense. Because in the end, that's a -3. You owe 3, -5, now you owe 5 more. Well, yeah, double signs in addition and subtraction. We're really always adding. I want to really say this straight up. When you have two signs, you're only adding. The only time we subtract is when we mix them. We have a positive and a negative number. Doesn't matter the order. I'm going to put subtract because I don't want to confuse it with substitution. So if we kind of absorb this factor that two of the same signs put together are being added versus two opposite signs are actually activating that subtraction, now we start to see math is a bit different because now 7 minus 3 makes sense. We're mixing a positive 7 and a -3. That's a subtraction of 4. A -3 plus 7 also makes sense because we are subtracting. And again, the subtraction is also a little bit tricky because keep sign of higher number. That's the only factor here to remember. Keep the sign of the higher number in any subtracting. So if you're in debt 13 or reversing that, in debt 7 and you paid $3, now you're in debt 4 minus 4. But these two will be more on the same side because they're going to be the same answer. And if I've swapped that positive 7 to a -7, now we have a -4 because the higher value is 7. And similar to the being in debt $7, paying off plus $3, now you still owe $4. That still applies. And even if we do it backwards, this form. A lot of students here get confused too. I mean, the earlier students, fifth, sixth, maybe seventh, sometimes even eighth grade, where they're looking at this and like, oh, that's 4. They're just subtracting. I have a 7, I subtract the 3. However, having 7 implies a positive 7. So just because we don't really teach students this thorough investigative factor of where a sign is associated, that negative minus is attached to 7. So we don't have 7 at all. We're removing 7. We have technically only $3. Robux, if you want to call them. That's the invisible plus at play. So then from $3, we owe 7. Uh-oh, we're in debt 4. But then we have these tricks and of the trade where we say, all right, keep the sign of the higher. But then your question is why? So your answer is, hey, because if you're in debt 3 and you're paying, or if you have $3 and you're in debt 7, you got to give someone $7. Well, technically now you're missing 4, subtraction of 4. So these are the kind of factors for considering PEMDAS, and this is just from the numerical standpoint. We haven't added variables to the mix yet. It's a little bit different with multiplication, so I really want to drop that in its own space for the PEMDAS, the A and the S of PEMDAS, because then we have some common issues with multiplication and division, the M and the D. of PEMDAS. It has a similar flow, but this is where it can get confusing. Because now we kind of understand the addition subtraction, and now we're entering another case for signing, and it's different but the same. And what happens when a negative multiplies with a positive? So that's why it's best to really snapshot this and practice this and get this to a good point of understanding. Because then if you mix these two together, you're probably going to end up kind of confusing yourself in the process. But the case scenario is let's see what it looks like. So if you're multiplying two positive numbers, no matter what the numbers are, because you can do the number math. And here's a case where I like to say, when you're multiplying numbers, do the sign first, then the actual numbers together. So if you have two positive signs, you're going to end up with a positive number. If you have a negative sign, two negative signs, you're still going to end up with a positive number. And this is where it's like, oh, wait, didn't we just see this with addition? Didn't it kind of like throw that weird sort of similar pattern involved? Well, yes and no. Because it's still plus and plus, two similar signs, negative, negative, two similar signs. And the output is a positive number. But we call this not really adding, we call this um, positive multiplication, or the result is positive. Now, the only time we get negative is when we take two negatives, or sorry, not two negatives, one negative and one positive. That's when we actually end up with a negative number, and vice versa. It doesn't matter which way you mix it. That's a little bit more straightforward. Like if you just remember this sort of pattern, it makes sense, and then it just kind of flows together when you're doing it. But the problem here is that mixing the numbers together can kind of get in the way. You forget about the sign, you focus on the multiplication of numbers. So something like 15 times negative 5, we would say I would do first a positive times a negative. That's what I'd focus on first, is a negative. So I know off the bat I'm going to have a negative number. And then I'll do 15 times 5. Some focus on the positive 15 times negative 5, and then they start to incorporate the negative into the equation, the problem, and then it just starts to get messy. And then you accidentally subtract somewhere by some form. So if you separate the actions as step one, do the signs first. There's your sign format. And then do the numbers 5 and 15. Well, if you haven't seen in the past, this is how I would do this math here. 10 times 5, and then 5 times 5. That's 50. That's 25. Add them back up, 75. And you got a negative 75. So focusing on the signs first gives you a bit more leniency. There you go. That Hashikoro, very good, very good. That gives you the focus on let's just get the signs out of the way. Then you can do the numbers without having to do, because I mean, the way I do the math here, and some of you will do the same, is you split it by the tens or zeros. Like if you have 115 times 5, then, well, you split it into multiple pieces. 100 times 5, 500. 10 times 5, which is kind of like still doing the typical multiplication you would normally do, but some just see it better this way. And 25. You know, add them all up, 575. Now you can still basically apply this in the format that we kind of learn as a cookie cutter process. 115 times 5, you go down, 525, there's that. Then you do 157, there's that plus that. And then what would I do? 55, 1, 5. No, there's no carry, right? 5. Yeah, no carry. And then the 5 left over. And then you apply this to that. Just basically adding them all together. So easiest way to multiply beyond the 0 to 10 multiplication table, which is recommended to. Oh, I got some tips on that too. Multiplication tables. Which ones to remember? I would remember really the 7, the 9, and the 5. From those, you can basically figure out the rest. But that's for another section here we might go over in a little bit. But still concluding on the current factor of just straight up multiplication. Division works the same way, so it doesn't really matter if you're multiplying or dividing. Here's the next step I like to think about PEMDAS. There's a type of association that we can gather right from the beginning, a pairing. And this is how I explain it to my younger students. You have addition and subtraction first. Adding is one type, subtracting is another type. The total opposites. It's like having a sibling that's totally opposite from you. You cancel each other out. One, I mean, kind of, sort of. One could be super quiet, the other one's super loud, but in the end, you don't really cancel. It's a middle of like average noise. But in mathematics, you're still considering them basically siblings with opposite characters. They cancel each other out. This is where it applies directly to variables when we start going into those. Then you've got multiplication and division. Same concept. Those are also siblings. Multiplication, division cancel each other out. Addition and subtraction, they go to 0. Multiplication, division, they go to 1. We'll see the difference when we're doing actual variables later on. But still, consider them siblings. The way they can relate is just by considering, hey, if I add 2 plus 2 plus 2 plus 2, mathematicians are lazy. We don't like to write this stuff all the way through. So there's a sort of cousin relationship. Let's get a little green going between addition and multiplication, where we take that set of numbers that we can write for a long time and just say, hey, that's just 2 times 5. The cousin comes in and replaces the sign. So there's definitely a relationship here between the two. The factor of really focusing in on this type of relationship helps us to uh, start seeing them relate much more often. Um, and this is why multiplication and division also work in the same factor with multiplying signs, same and different. So multiplying and dividing. The multiplication, division, both play a role here. Oh, I'm gonna take this headset off because it is hot up in here. Oh, I think I might get some coffee and take a small break. Mm, yeah, take a quick coffee break. Long as a balloon. I think I'm gonna reset stream each time I take a quick break. So I'm gonna reset this actually.